Robert Dijkgraaf is directeur van het Amerikaanse Institute for Advanced Study. Ooit de thuisbasis van Albert Einstein. Dijkgraaf woont op het terrein van deze vrijplaats van de wetenschap. Hij neemt ons mee naar wetenschappers die hun leven wijden aan de wereld van morgen. Denkers, dromers, verkenners, zoekers. Hun kennis verspreidt zich over een wereldwijd netwerk. Als we al die kennis verbinden, wat gaat dat voor ons betekenen? Zijn wij dan het denkende deel van het universum? The mind of the universe?
De mens bezit een onmiskenbare evolutionaire drang om te verkennen. Zo vindt hij nieuw voedsel, nieuwe grondstoffen, nieuwe kennis. Verkennen zit diep in onze genen, want verkennen is overleven. Het is onze rol in het universum om alles in kaart te brengen en te benoemen. Zo komen wij te weten hoe de wereld, ons universum, in elkaar zit. Maar er blijven altijd plekken die we nog niet kennen en vragen waar we nog geen antwoord op hebben. Wetenschappers zijn de moderne ontdekkingsreizigers. De mens probeert voorbij de horizon te reizen, ook voorbij die van de eigen sterfelijkheid. Al zolang als de mensheid bestaat, wordt er gezocht naar manieren om onsterfelijk te worden, om de strijd met de dood aan te gaan. We onderzoeken de rol van voedsel, van genen, van sociale structuren. Maar het punt is dat er niet één levenselixer is. Heel oud worden blijkt veroorzaakt te worden door een combinatie van factoren. Het zijn precies die factoren waar de demograaf Michel Poulain op uit is. Hij brengt gebieden in kaart waar mensen het oudst worden. Op Sardinië bijvoorbeeld. Blue zones heeft hij ze genoemd.
This village there is included. It's included in the blue zone, as well as the neighboring village. So you have really an area like this, you see, where the longevity is the highest. And when I did it for the first time, I put it in blue. So this is really the highest blue zone of Sardinia, you see, and the rest of the country is a non-blue zone. It's without longevity. The fact that we identify a blue zone and a non-blue zone, now we are comparing the lifestyle, the food, the environment, everything in the two part, and then we will see what are the biggest difference. On the scientific viewpoint, you have to find something. If there is a secret, you have to find it. I name it a longevity quest. When you go from one village to the other one, every time you find new centenarian. In the mountain area, there is a non-random distribution of centenarian. In most of the study, they are doing study on centenarian that are there, a bit everywhere in the city. Here, we are working with what I name population longevity, which means the whole population is living longer.
Poulain onderzoekt geen individuele gevallen van langlevenden. Hij neemt juist hele gemeenschappen onder de loep. Het zijn vaak geïsoleerde groepen op afgelegen plekken die in de loop van de geschiedenis overeenkomstige erfelijke eigenschappen hebben ontwikkeld.
How many centennials are lying here?
A priori, you may find in the whole cemetery 30. Plus those who are alive, in total you have more than 42 centenarian. Usually you should find among the centenarian 8 women for 1 man only. Here you have the same number. That's crazy. I have another one here, look. This one, for example. You see, Fortunato, he was 101 when he died. You are dealing with an interdisciplinary approach, which means that you have an information from environment, from nutrition, from anthropology, from sociology, from demography, from genetics, and even now from epigenetics. Epigenetics is a new way to enter in the study of longevity. It's the interaction between genetics and environment. And we are convinced, we tried to do something in Sardinia with genetics. We did not find any genes that may explain the longevity in Sardinia. But why? Because we need 3,000, 10,000 centenarians to reach a weak conclusion in genetics. In epigenetics, and that's very attractive, with 200 persons, you may already conclude something. And what is good is that usually they are now doing epigenetics on centenarian. Here we will do epigenetics on a population that has common trait. So we are in the best condition to see if there is some epigenetics of longevity. Allora, come va? Tutto bene?
Ciao, dottor Pulenti.
Tutto bene?
Tutto
Ok.
bene.
Allora, il
Andiamo
municipio è aperto?
Tutto aperto.
Living longer is something very attractive. It attracts so many persons. When I do a conference on longevity, everybody is there attending the conference, very happy to listen. What are the secrets of longevity?
Hoe wonderlijk is het eigenlijk dat wij onderdeel zijn van een voortdurende keten van het leven. Beginnend bij de allereerste organismen, zo'n 4 miljard jaar geleden. Dat begin is nog steeds een groot mysterie. Ooit moet uit de dode materie leven zijn ontstaan. Maar hoe? Is het een uniek aardsproces geweest of kan het ook elders in de kosmos zijn gebeurd? Tot nu toe is er maar 1 planeet in het universum waarvan we absoluut zeker weten dat er leven is. Dat is onze eigen aarde. Ze wordt wel eens de Indiana Jones van de sterrenkunde genoemd. Astrofysicus Sara Seager. Haar leven is 1 grote ontdekkingsreis en ze is vastbesloten om leven op een andere planeet te vinden. Seager ontwikkelt aan het Massachusetts Institute of Technology een nieuw type satelliet waarmee het mogelijk moet zijn om de atmosfeer van ver weg gelegen planeten te bekijken. Daar moeten sporen van leven in te vinden zijn.
Ever since I was a child, I always wondered what is out there. When I saw the sky for the first time, the dark sky, really, really dark, tons of stars. It's like so many stars, I couldn't believe it. I'd never even known that that was out there. Ever since I saw those stars, part of me has always wondered what else is there. I'm sure there's life out there somewhere. Everywhere we look, we see the ingredients for life. Stars can provide energy. There will be planets that have liquid water on them. And so it seems inevitable that if life arose here on Earth, that it should also be able to arise on another planet somewhere else in our galaxy. There's a harder problem though, because I am convinced that life is out there somewhere. But the chance of us finding signs of life is a whole other question. And that's a very, very, very challenging journey. I work on planets orbiting stars other than the sun. We call them exoplanets. Every star in the sky is the sun. Our sun is just one of billions of stars, hundreds of billions of stars, orbiting, all bound together in a galaxy we call the Milky Way. Yeah, so many stars.
Sara Seager zoekt planeten die zich in de zogenaamde Goldilocks-zone bevinden. De leefbare zone van een ster. Deze exoplaneten staan op de juiste afstand van een ster, waardoor eventueel leven mogelijk is. Net als de aarde van de zon.
And now we actually think that every star has a planetary system. So if there's hundreds of billions of stars, there could be trillions of planets in our galaxy alone. And actually, there are hundreds of billions of galaxies out there. That's one followed by lots of zeros. Everywhere we look, every star that our technology can find a planet around, we do find a planet, almost every star. There's a space telescope, Keppler Space Telescope, and Kepler's goal was to answer the question, how common are other Earths? And for various reasons, Keppler fell short of that goal. But Keppler did tell us that small planets around stars like the Sun are very, very common. Let's go to Keppler 186. Typed in the name, it's giving us the results here. And out of this real map of the sky, the software will zoom in to where Keppler 186 is. See here? Look how many planets there are. Nice, huh? I can tell you that this planet is in the Goldilocks zone. It's one of 5 planets orbiting its host star. All of these planets are transiting the star. And it's exciting because it's one of the first planets we have that we believe is rocky, that is in the habitable zone of its host star. Now you can see here, the habitable zone is very wide. We know the mass and/or the size of the planet. But what we don't know is anything about the planet atmosphere. We need to know what the greenhouse power is, how massive is the atmosphere, what is in the atmosphere, to know whether the planet is habitable. So in fact, at the moment, we don't know. We don't know if it's habitable or not. But I'd say our biggest problem at the moment is that the planets we have found today that are in the habitable zone are not the planets we can follow up tomorrow with our new space telescope. So that's a bit of a problem right now. We're able now to get a census to take data and find planets, but we're not able yet to observe their atmospheres. We'll need a new set of planets that are suitable for atmosphere follow-up to find them.
We beschikken dus over de meest geavanceerde apparatuur om de sterren en planeten om ons heen te bestuderen. We kunnen zelfs bijna 14 miljard jaar terug, naar het moment vlak na de oerknal. Daar ontstonden tijd en ruimte. Sterrenstelsels, zonnestelsels en planeten. En 4,6 miljard jaar geleden ook de zon en de aarde. Al die tijd woedt die oerkracht voort, in de gloeiend hete massa in het binnenste van de aarde. En af en toe laat die oerkracht zich zien, op de breuklijnen in onze aardkorst. Op die hete massa drijven de continenten. Ze bewegen langzaam en vernieuwen zich. Platentectoniek. De Noor Trond Helge Torsvik richtte een speciaal centrum op om de diepe aarde in kaart te brengen. Als een moderne Jules Verne zou hij het liefst afdalen naar het binnenste van de aarde, om daar met eigen ogen te zien hoe de aardkorst zich steeds weer vernieuwt. Helaas is dat onmogelijk. Maar gelukkig komen op sommige plekken de randen van de platen naar boven. Bijvoorbeeld op IJsland.
We are the only planet in the solar system where you see this, because we are the only planet with plate tectonics we know about. So you won't see this when you land on Mars or Mercury or wherever. We are very preoccupied thinking about life on other planets. I'm more excited we are the only planet with plate tectonics. And we don't really understand why we are the only planet with plate tectonics. And so we're actually looking at a phenomena which we don't fully understand, but which we hope one day to solve. Now we're working from what we call the Eurasian plate, and now we are crossing into the North American plate. Yeah, this is exciting. I'm more fascinating going back in time you know, hundreds of millions a year, billions a year. And fascination is then how plate tectonics move continents around on the plates and they collide, and how this shape the Earth through time. That's my fascination. And it's like history, but really old history. How it all evolved through time.
Binnen in onze eigen aarde valt nog een hele wereld te verkennen. Torsvik is een van de bekendste geologen van dit moment. Hij bestudeert de manier waarop de continenten bewegen en hoe er door de tijd heen materie uit het binnenste van de aarde naar boven is gekomen.
Geology in general, also plate tectonics, kind of is important for everything on this planet. So we, whether it's mineral resources, whether it's drinking water, whether it's wine or rocks for the road, it's all about geology, even diamonds and so forth. So without it, there wouldn't be any cars. We need something to build this thing, and we need something to fuel it. Maybe in the future we have other means, but still you need minerals, even if you're going to turn into batteries and so forth. That's extracted from rocks. Again, it's geology and plate tectonics who actually, in some way, you can say, gives us all the resources to do what we want on this planet. Wow. Clean and tidy. We don't take this? Yeah. I think we only need one. Yeah. Okay. Hammer. Okay, all ready? Adventure of lifetime.
Het oppervlak van de aarde verandert continu. Continenten verplaatsen zich, vallen uit elkaar en voegen zich weer samen. Ooit zaten Zuid-Amerika en Afrika aan elkaar vast. IJsland ligt precies op het breukvlak van twee continentale platen. De Noord-Amerikaanse en de Eurasiatische plaat.
This rift here, or spreading ridge, started at about 55 million years ago. That's when Europe and North America was very close. So it started almost along the coast of Greenland. And then it has changed its position. And at the moment, we have a big North Atlantic Ocean. This is kind of in the center now. It's a very slow process. I can make maps what the Earth will look like in 10 million or 20 million years, but I will never be there to see if my maps are correct.
Dat is soms de tragiek van de verkenners. Ze doen het werk. Ze ontdekken, brengen de wereld in kaart en rapporteren. Meestal zijn hun bevindingen pas veel later relevant. Vaak als ze er zelf niet meer zijn. Wetenschappelijke theorieën hebben data nodig. Zonder gegevens geen model. De verkenners verzamelen die data. Een proces dat soms vele jaren kost. Demografie is zo'n vorm van verzameldrang. Demografie, letterlijk betekent het volksbeschrijving. Dat is ook precies wat Michel Poulain doet. Alleen op die manier kunnen we uiteindelijk te weten komen waarom sommige mensen veel ouder worden dan anderen.
Since I was very young, I remember I was probably 6. I have already map on the wall in my sleeping room. I think the first thing that interested me was geography. So I try all the time to travel. And this opportunity of demography and on longevity bring me in so wonderful place. And if you want to say something, you need to compare with other places. And that's what I'm doing, to meet people and to interact with this population. And there is really question beyond. How is it possible that this situation exists?
De verkenner gaat op zoek naar de ruwe kenmerken, de ruwe data voor zijn onderzoek. En Poulain moet daarbij soms hele eenvoudige vragen stellen. Want wat voor de mensen in de Blue Zone zo gewoon is voor de wetenschap een groot geheim.
La questione principale è qual è il segreto della longevità per lei. Che deve fare per vivere a lungo?
Per vivere a lungo, mangiare bene e anche male. Ho mangiato tanto minestrone. Fave con lardo e patate e ho camminato molto.
Abbiamo passato tempi duri, povertà abbiamo passato. Quando eravamo giovani andavamo a lavorare in campagna, a fare tutto.
Poi ho portato acqua buona, acqua naturale, fresca, e poi mangiando cose naturali.
Cose naturali.
Anche prosciutto, anche...
Prosciutto del villaggio. Sì.
Facevamo la provvista, mangiavamo minestrone, di legumi e tutto cose non ce n'erano.
Yogurt, cacao, coagulato in estate. Ho mangiato tanto coagulato.
I will not say that they have a Mediterranean diet. They don't have this Mediterranean diet because, for example, somebody will say that take fish. Yeah, but if you look, the fish, you have 28 kilometers from the sea, and in the past, the fish never arrived here. So it's not the fish, it's meat. They have meat, and they eat quite a lot of meat. They have fruit, and they have vegetable. But what is the two important thing is that this is locally produced food. So I will say that compared to our Western society, 90% of what they appear on the table is locally produced. It's not fast food. It takes time. You may have 2 or 3 hours around the table, large family, and they eat. They eat maybe too much. I don't know, but the social dimension of the meal is very important. Perché il babbo e anche il marito sono centenari.
Mio babbo era pastore, sempre pastore da ragazzino, e fino a 85 anni era pastore.
Dietro il gregge, montagne dell'Argento, qua a Orguda, queste montagne, e ci faceva tanta strada. Di là, di qua a là sono 80-100 chilometri, ma dietro il gregge ce ne facevi più di 80 chilometri. A sinistra, a destra, andando avanti il gregge. E se la longevità per me si mangia, stando sempre all'aria aperta.
That's why the Blue Zone is concentrated in the area where you have this pastoralism, where you have everybody is working on the animals in the mountain.
Uitgerust met 5 zintuigen verkent de mens het universum en noemt zijn ontdekkingstocht wetenschap. Een uitspraak van Edwin Hubble, een man die letterlijk liet zien hoe groot het heelal is. Hubble verkende de hemel met zijn telescopen en toonde aan dat veel van de nevels die we 's nachts zien feitelijk enorme sterrenstelsels zijn, met miljarden sterren die haast oneindig ver weg staan. Inmiddels weten we dat rond bijna al die sterren ook nog eens planeten draaien. Daar moet gewoon ergens leven zijn, dat kan niet anders. Carl Sagan zei ooit, als er alleen hier leven zou zijn, is dat wel een enorme verspilling van ruimte.
Yeah, this is good for scale too. Oh, look at the little test model. That's perfect.
Yeah, we should
Put it with it, yeah.
It's a little out of scale and stuff.
That's okay. So this electronics board is going to end up...
Yeah, each camera, I think, has 2 boards.
Okay.
Different groups of people all around the world have different projects they're trying to move forward. The ones I'm involved with, one of them is called TESS. TESS is a satellite that will orbit Earth. And in 2 years, TESS will survey the whole sky, looking at stars, measuring their brightness as a function of time, searching for planets that transit their host stars. They go in front of the star, and they block out a tiny amount of starlight while they're transiting. And the goal for TESS, actually, is to uncover a pool of planets, of rocky planets, transiting small stars, stars much smaller than the sun. And those stars and their planets are the first ones that we'll be able to search for signs of life in the atmosphere. Our own Earth, actually, blocks out about 1 part in 10,000 the light of our sun. If there's an alien civilization looking back at us, and they have a Keppler space telescope, they need to measure a star to a precision so they can see a drop in brightness of 1 part in 10,000.
But they don't have a Keppler telescope.
Who the aliens?
Yeah.
Oh, they might. They might, actually. Because Keppler was the easiest telescope for us to build, actually. So I'm just setting the stage for you to see just how hard planet finding is. 1 part in 10,000. I mean, do you ever have to measure anything to 1 part in 10,000? So I can't wait to see the data you got yesterday. I'm sure it doesn't look any different from the data before, but I was so excited about it.
It does look different. Yeah, I can pull up my laptop.
That'd be great. I guess you don't know because the X-ray source is going off and it's emitting X-rays in random. So imagine we're looking for a planet like Earth, and it's faint in and of itself. But that faintness is not our problem in astronomy. It's the fact that the Earth out there we're looking for is right next to a very bright star. The star is 10 billion times brighter, so we have to suppress the starlight or block out the starlight to 1 part in 10 billion. So the star shade, if you will, is like our next step after we finish with translating planets. We're going to do what we call direct imaging. We're going to block out the starlight so we can see the planets directly. And we already do this from ground-based telescopes. Only we're reaching 1 part in 100,000, not 1 part in 10 billion. This is showing you the starshade and telescope launching together. They separate in space and the starshade petals unfurl from their stowed position. The central truss will expand for the second stage of deployment of the petals. There's the starshade at tens of meters in diameter, and it has to be made so precisely. The petals have to be manufactured to within 100 microns tolerance. And the starshade has to fly tens of thousands of kilometers from the telescope. All of that aligned just so it can block out the starlight precisely enough so we can see planets without the glare of the star.
Sara Seager had een logische gedachte. Dat als er ergens anders leven is, er ook gassen zouden moeten zijn die door het ons bekende leven worden uitgestoten. Gassen zoals kooldioxide of zuurstof. Als ze die ergens zou kunnen meten, zou dat mogelijk een bewijs voor buitenaards leven zijn.
Despite this excitement that I might have come across this concept that life produces all gases, it turned out to be completely wrong, actually. And it's not so. It's only true that life produces about 1/4 of those gases, 1/4 of everything. But we found something even more interesting, actually, on this journey, that in the set of molecules or molecular fragments that exist in general, that there's certain pattern amongst the fragments of molecules that life doesn't produce. So life seems to prefer producing some types of molecules, and other types of molecular fragments life never produces. And so right now we're pursuing that avenue of research. And we're not at the point where we can say that we found something amazing, but I really feel strongly that this is going to be awesome.
Wetenschappers moeten voorzichtig zijn met hun uitspraken. Ze verzamelen informatie en denken een patroon te zien en hopen zo nieuwe kennis te vergaren. Verkenners zijn mensen die grenzen durven te verleggen, die niet bang zijn aangelegd en altijd verder willen reizen. De drang om te ontdekken waar bergen zijn ontstaan en hoe ze over de aarde bewegen, dat is het terrein van Torsvik. Daarbij bouwt hij voort op het werk van andere verkenners die voor hem de oceaanbodem in kaart brachten en tot een wonderlijke ontdekking kwamen.
In the most southern part of Iceland, we're standing on the rift on solid basalt terre in Iceland, but we're looking south now. And this is a very historical site because in 1963, two Englishmen from Cambridge, they had done boat profiles going back and forth and down in this direction. And they discovered that they had this pattern of magnetic anomalies which was parallel to the spreading axis. And that actually was the first proof that actually you had seafloor spreading. So this is the second revolution in Earth science, seafloor spreading, that actually the plates are moving apart. So this is a really historical site.
Pas in de jaren 60 dus kwamen wetenschappers erachter hoe de zeebodem uitzet. Door de breuklijn onder de oceaan bij IJsland te onderzoeken. Tussen de twee continentale platen komt voortdurend magma omhoog, waardoor er steeds nieuwe zeebodem ontstaat. De continenten worden zo uit elkaar gedrukt. Zo verandert de aarde, heel langzaam maar onverbiddelijk, haar oppervlak. Maar hoe kun je het binnenste van de hete aarde onderzoeken?
Beneath us is a volcano. One of four in the area. They're called central volcanoes. This is true power. So this is the, it's a very high geothermal gradients here because you have a volcano beneath you. But luckily, last time it erupted was in 1220 or something, so hopefully it doesn't go today. But of course, it's very hot. So the groundwater, which is percolating into the crust, gets superheated, and so we get all these vents there, and a lot of sulfides and algae, hydrothermal algae.
De ligging op de breuklijn zorgt ervoor dat IJsland stoomt en borrelt en dat er regelmatig een vulkaan uitbarst. Maar dat zijn relatief kleine uitbarstingen. Het kan veel ernstiger. Het eiland drijft op een enorme kolom magma, die direct in verbinding staat met het hete binnenste van de aarde.
Iceland hotspot started like that, but that's about 60 million years ago. But then it wasn't just confined to a little island like Iceland. It maybe had a radius of something like 1,500 kilometers, maybe 2,000 kilometers. So that's what we call a supervolcano, and you do not want to be around when one of these erupts. For comparison, one in Siberia about 250 million years ago was 5 million square meters. And that one actually affected life on Earth, and maybe 90% of all life died because of the supervolcano. So if it happens again, it's definitely something to worry about. If it hadn't been for this plume, very deep plume, which gives it the buoyancy, and this would be underwater. This would be just a normal spreading ridge underwater. So we wouldn't be able to sit there in the bar if it hadn't been for this extraordinary, that you have what we call a mantle plume, which is interacting actually with the spreading center and keep this high up.
We denken dat 99,9% van alle diersoorten die ooit op de aarde hebben geleefd, zijn uitgestorven. Uitsterven door catastrofale gebeurtenissen is vrij normaal. Vele verzwolgen door de turbulente dynamiek van de aarde of een botsing met een ander hemellichaam. Maar het leven is sterk en weet zich toch al meer dan 4 miljard jaar te handhaven. En de mens? 7 miljard exemplaren lopen er inmiddels van ons rond. En we blijven steeds langer leven. Er is berekend dat we sinds de eerste helft van de 19e eeuw elke 4 jaar gemiddeld een jaar ouder worden. En de reden? Onze levensomstandigheden zijn dramatisch verbeterd. En dat heeft ook direct effect op ons erfelijk materiaal.
Having this very positive aspect in the mountain, fresh air, fresh water, good food, no stress and so on, may have an impact on your children and on your grandchildren. And it comes through epigenetics, because there is a transmission from generation to generation of some trait coming from epigenetics. You may have these good genes, but due to the environment, it is not activated. And that's very important. Or you may have a bad genes, but also due to the fact that it's not activated, you will not be disturbed by this. So the role of the environment is very important. And this is a very good message for the society, because for me it will be crazy if I conclude with my study here that there are two kinds of people, those who have these good genes and those who does not have. If there is a longevity genes, and somebody has the longevity genes, no problem. He may do what he wants. He will live longer than the other one. Can you imagine? This is deterministic. There is no solution. But now, the good point with epigenetics is that you may activate or not activate those genes. You may do something yourself, and you may even take advantage of what your parents and grandparents did. And maybe the secret is that a lot of these ancestors were shepherds and has a wonderful life with wonderful situation, with physical activity, food and so on. And it may explain the difference between male and female, and it may explain why the longevity is the highest. Io so 79. Doing study on the oldest old, you have all the same time the idea I will be there soon. And that brings me a lot of thought, sometimes negative, so I have to fight against the negative. But I have seen this person. The longevity is in front of all of us. Why marriage, children, and so on, this is beyond. But longevity is in front.
Mijn kinderen zullen naar verwachting ouder worden dan ikzelf. En hun kinderen zullen misschien allemaal ouder worden dan 100 jaar. Als het leven oprekt, hoe slaagt de geest er dan in om bij te blijven? Of worden we uiteindelijk lege omhulsels? Het kan ook zijn dat we erin slagen onze geest levend te houden. Er zijn genoeg organismen die lang leven en goed functioneren. Olifanten, schildpadden. Onlangs is er een haai gevonden die 400 jaar heeft rondgezwommen. Wie weet wat we elders vinden, diep in de rest van ons heelal. Sara Seager weet het ook niet. Haar instrumenten zullen eerst nog geperfectioneerd moeten worden. Meer data, nauwkeuriger metingen en uiteindelijk scherper zicht.
Sometimes I feel like I'm in a wilderness. It's like we're only outfitted with the most rudimentary gear. I'm usually working, and the best thing is I'm in the zone. Then everything else goes away. It's just like you and yourself and your work. You know what you can expect is that in time, I'll be able to report to you one way or the other whether or not we think we have found signs of life on another planet. But that wasn't tomorrow. That's like 20, 30 years from now.
Can you talk when you were in the zone?
Not really, no. I can't talk, no. we're not going to find big, scary monsters. We're just going to see gases produced by those aliens.
But suppose they are big monsters.
If they're big monsters giving off gases, we still won't know. We'll just see the gases that don't belong. We'll do our best to disentangle that from any volcanic emission, and we'll try to understand if it's created by life or if it's just what we call a false positive. Oh, nice.
Yeah.
Is Jupiter out right now, though, or do we have to
Yes.
wait till it's really? Okay, what else? Do you know what else is out tonight?
I think Sirius is this setting. I believe Arcturus is out.
We're not going to go camping, or we're not going to go there and work through the wilderness. Half of it's in our imagination. We're going to see a point of light, like just a pale blue dot or a pale red dot or just some little tiny thing. And we're going to put a picture together based on scientific tools.
I need to find north now.
Okay, well, let's see. And that's how we're going to know if we found another Earth. So it's our modern day version of exploring. What would you like me to do? Okay, how does it look?
Looks good, actually.
Can you tell how great the telescope is?
Well, wait till it gets a little bit darker.
Oh yeah, that's pretty awesome.
Let's make sure that's a lot.
Hoe kijken verkenners? Hebben ze direct een oordeel over wat ze zien? Een goede verkenner heeft de open blik van een kind, anders vindt zij geen nieuwe wegen. Tegelijkertijd is zij de ervaren wetenschapper die de juiste gegevens aan elkaar koppelt. Je ziet pas iets als je het begrijpt. Is er misschien een samenhang tussen het karakter van de verkenner en het onderzoeksveld?
Normally when I want to drill something, I want to be away from people. I don't want to drill in the backyard of people. Very often when we start drilling, sometimes people have been running after me with shotguns and wondering what I've been doing. Got police on our drilling site wondering what we're doing.
Torsvik wil de allesomvattende theorie van de geofysica vinden. Omdat het onmogelijk is om in de diepe hete aarde zelf af te dalen, zoekt hij in de sporen van het afgekoelde magma, onze rotsen. In de stukjes steen die hij uitboort, kan hij lezen waar op aarde die rotsen hun zwerftocht zijn begonnen, miljoenen jaren geleden.
Okay, we have to see if it's standing. And that was a winner. So now we have to put in my little orientating device. We have to orientate it. We have to know exactly how it got out of the rock. Radar ready to ride down?
Yes.
Okay. There we are. So this basalt should be 10, 15 million years old. Normally I'm more interested to find out where this lava came from. But this is so young, so Iceland hasn't moved very much. If I took you to Oslo, we have volcanoes which they are about 300 million years or a little younger. A lot of them, big. I sometimes say my students, Oslo is a really boring place today, but 300 million years ago, this was almost like Iceland. When I take out the core from these volcanoes in Oslo, I will see that they were actually formed at the equator and not 60 degrees north where Oslo is today. I'm interested in what are the driving forces and how does they fit in with these hotspot and plumes? Is there a relationship between them? And kind of the name we have put on this preliminary, we call it mantle dynamics. So we get a mantle into this as well. It's more making a grand theory, In some way, that's what we want to do with Earth. We want to link the full understanding what's happening on the surface, what's happening beneath us, all this heat and the plumes and so forth into one unifying theory.
Well, in my dreams, planets are everywhere. They really are, and they're just waiting for us to find them. And I literally dream of the data we're going to be getting. And I know it's not going to be spectacular data. It's going to be, our first try. And I literally dream of the data coming down and finding what we're looking for. And I believe in my dreams so strongly, that we'll be finding oxygen and other gases that don't belong. But my dream goes a lot further because at some level, I do know I may not accomplish everything I want in my lifetime. And so my dream extends to my students, some of them who are really like my own children. And I want them to carry the dream on, actually. And so I do dream of an amazing future, well beyond what I'm going to accomplish in my life. And in my dream, I'm still alive then. I'm just 100 years old, traveling around to conferences and getting to enjoy the success of the seeds that I planted. You know what I always wonder when I look at the stars? I always wonder if there's a planet around those other stars, and there's some kids on that planet pointing their pointer at our star, our sun.
I see aliens.
Okay.
No, I'm just kidding.
What do they look like? Do they look like in a movie?
I see a big planet with 4 other planets around it. The big planet kind of has faint stripes if you look really
There you go.
closely.
And guess what planet that is, It's
Venus.
Actually, no. No.
Yeah, I know, I was kidding.
Okay.
Verkenners, ze zoeken, speuren, eindeloos. Ze durven te falen, omdat ze weten dat ze ook daarvan leren. Hun kaarten wijzen de weg naar de kennis van morgen. Wij staan op de schouders van de verkenners die voor ons uit zijn getrokken en we zien door hun ogen wat zij ontdekt hebben. Wij vertrekken waar zij geëindigd zijn. Zo ontdekken we weer meer van onszelf en het universum. Dat is the mind of the universe.
Iedereen kan de complete interviews van The Mind of the Universe downloaden via de website. Ontdek unieke fragmenten die je niet zag in deze uitzending. Of creëer je eigen programma.
I hope you enjoyed this episode. If so, you can find the next one on this website. If you're interested in other recommended series, please check out our channel. If you want to stay informed about new projects and series, please subscribe to our channel.